let's take a look at graphing polar equations. And we're going to look at kind of a simple one and to give it a try. So first, what is a polar equation? Well, instead of an equation involving x and y, this equation involves r and theta. And for this example, right, we're looking at the polar equation, r equals 2 times sine of theta. And without more experience or exposure to this kind of thing, the best way to graph an equation like this is to make a table. And so that's what we're going to do here. So I'm going to have an r column for my table. I'm going to have a theta column for my table. And I don't know how much table I'm going to need. And then I want some ordered pair because, again, that's like really what I'm after is points, right? Because if I can find points that belong to the equation, then I'm able to graph the equation. Notice that I'm starting with a polar grid here. It makes it easier to graph things in terms of r and theta. Okay, so I'm going to start, say, with the angle 0 radians. If I have that, what is r? Well, r is just 2 times sine of the angle that I'm picking. So if I pick the angle 0, then r is going to be 2 times sine of 0. Sine of 0 is 0, so this is just 2 times 0, which is 0. So I've come up with a point where my r and theta are both 0. So if I want to plot that point, that's going to be right here at the origin. Okay, let's try another one. How about if I picked the angle pi over 6? So where is that? Well, I would have 2 times sine of pi over 6, which is 2 times 1/2, which is just 1. So radius of 1, or r value of 1, when the angle is pi over 6. So where is pi over 6? So let's remind ourselves, like, out of all these lines, this one's pi over 6, then pi over 4 for the main diagonal, and then pi over 3 for the one right above it. So those are the ones that I'm going to kind of be focusing on. And so what this tells me is that at the angle pi over 6, I can even label it on here. So here's pi over 6. I go out 1 unit along that terminal side. So 1 unit would be right here. Okay, just looking at my scale. Okay, so let's do another one. How about pi over 4? Okay, so 2 times sine of pi over 4 is 2 times root 2 over 2, which is just root 2. So I get root 2 comma pi over 4. Well, root 2 is about 1.4. So when I go to graph this one, here I am at pi over 4. How far do I go out? I go out about 1.4. Okay. So I need to decide on a color here. We'll do dark. All right. So if I'm at pi over 4, then I go out 1.4. So just right about here. Okay. Let's do another one. How about pi over 3? Well, 2 times sine of pi over 3 is 2 times root 3 over 2, which is root 3. So this is root 3 times root 3 comma pi over 3. So on this pi over 3 angle, I need to go out root 3. So I remind myself what's the value of root 3, just so I can kind of place it, about 1.75. Okay, so that would put me almost right in the middle of those 2 circles there. Okay? All right, and again, I can use any angle, right? But I'm just using angles that are nice kind of in my unit circle to start with. 2 times sine of pi over 2, which is my next angle, is 2 times 1, which is 2. So r is 2 when the angle is pi over 2. So pi over 2 is this angle going straight up. And my point needs to be 2 units away from the origin at that point. Okay, so I'm making some progress. All right, what about when I kind of turn the corner? So how about 2 pi over 3? Well, I know that when I have 2 times sine of 2 pi over 3, well, this is just 2 times root 3 over 2, right? Because I'm in quadrant 2 of the unit circle where sine values are still positive. So this gives me root 3 comma 2 pi over 3. So that means that when I'm over here at 2 pi over 3 in quadrant 2, I need to be the same distance away as I was for pi over 3. So I get a little symmetry in that graph. All right, let's keep going. How about 3 pi over 4? Well, 2 times sine of 3 pi over 4 to root 2 over 2, which is root 2. So I get root 2, comma, 3 pi over 4. Okay, so that's about 1.4 out at the angle, 3 pi over 4. So it's a little bit arduous work here, but we're getting there. Okay, so I'm starting to see the symmetry happen, and so I'm going to just draw in my 5 pi over 6, where I'm expecting that to be, which it should be right at 1. Okay. And then the last one I'll do here for now is looking at pi. 2 sine of pi is just 2 times 0, which is 0. So that gives me 0 comma pi. So if I'm out on the pi terminal side now, it says don't go out at all, stay at the pole. Okay, so I'm back here at the origin. So I can do more, more points than this, but what it ends up giving me is a circle. And the circle is radius 1, right, diameter of 2. That goes from, y equals 0 to y equals 2 there. If I'm thinking about it in rectangular coordinates. So I get this nice little circle. So how do I know there's not more to the graph? Well, I could certainly keep going, right? I could say, well, how about 7 pi over 6? It's kind of like the next angle I know. 2 times sine of 7 pi over 6. It's 2 times. This is going to be negative 1/2. So I get a negative. So, what's going on there? So this is negative 1. Well, the problem is I have this negative r value now, right? And I will be getting negative r values for all of the angles between pi and 2 pi, because sine will be negative there. So what's that going to do? Well, let's find 7 pi over 6. It's going to be down here in quadrant 3. But remember what this says. It says, don't even go out on that ray, right? Like, I'm too scared to walk out on it. I start backing up and going this way. Well, how far do I need to back up to not go on there, right? Well, negative 1 says I need to be 1 unit away from the pole, but in the opposite direction. That's just back here again at one of my first points. Okay, and the same thing is going to happen. I'm going to go out at 5 pi over 4, and it's going to send me back up this way with a negative r value. And 4 pi over 3 is going to send me back up here at pi over 3, etc. So it's just going to be kind of going over itself again. And so these are all of the angles that I need. So this is just a demonstration of how to graph a pretty straightforward polar equation where you can make a table of some unit circle values, be able to, plot the points and, kind of see that in this case we get a circle.